sir, good evening. This is my video about the 2-bit binary combinational multiplication. So x1, x0, then y1, y0, then p3, p2, p1, p0, then x equal to y, x1, x0, then y equals y1, y0. So to define the unknown product, so we need to use table. So we need to multiply x1, then x0, then y1, then y0. So we need to cross multiply then. So x0, then uh, y1 so here, then x1 y0 so here, and then uh, um, x0 is right, then tapos x0 then xy then x0 then y0. So we have here the x, so the variables, the product of x, so yeah, here. And then so to find the to to add the product, so we need to x1 then y1 then x0 then y0, so equals to carry 1. So we need to move here, then we need to put the carry 1 here and then add the x1 and y1. So carry 1 plus x1 plus y1 equals to carry 2. So we need to put here the carry 2. Then next, so we should have to drop the p3, p2, p1, and p0. So we need to implement here. So p3, p2, p1, and p0. I know p0, so p0, then 1, then 2, and 3 rather. So the p0 here is the x0 and y0. Then the p1 is the so the p1 is the uh, x1 then y0 plus x0 then y1. So here, and then the p2 here. So so the p2 is um, x1 plus x1 then y1 plus c1, and then the p3 here is c2. After that, we need to check. So we need to check. So the x and the y. So the x is 1 1. Then the zero and the y is 1 0. So we need to multiply. So 1 times 0 equals 0. Then 0 times 1 0. Then 1 times 1 equals 1. Then 1 times 1 1 over. So the result is 0, then 0, then 1 1. So we should have to here the 3 and then 2. So of course, we need also here to multiply the two variables. So, I mean the two numbers. So 3 times 2 equals 6. So now let's proceed to the multi-logic to see if, the outcome. So we have here the laboratory. So the x0 here, which is the input 1, is the x0, then y0, then 1 0 equals 0. So the p0 equals 0, and then the y0 is here the second. So the number here is the 1, then 0. So 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 here the gate of this given. Then here the x1, then xy, x1, then y0, so it's the number 0. Then the y0, then the number also here is 1 and 0. Then here, so the p1 is 0, xor 1 equals 1. So the gate of xor is this logo. So here, okay, later we need to ano first. So here the x0, then the y1, so 1 1, 1 1 number, and then x0 y1, so then 1 here, then c1 0 and 1, then equals to 1. So the p2 here, so 0 0 again, then xor, then 1 equals 1. Then here, yeah, and then the last one is the x1 y1 again, then 1 1 here, then x1 y1, then number is 1. So here the 1 0, then c2, so then p3, then 0. So to connect. So the x1, the x0, the y0, so two inputs here. This given, so two inputs here. So we need to put this the what we call this icon, then the AND gate, and then um, um, the series of this. So we need to the wire. We put wire here, and then yeah, and then here here AND gate, also AND icon here, and then here is the XOR. So it means they not the same. So it is because x1 then y0. So not like here same number. So here is 1, which is the prime, and then here is x, then 0, then here. So the overall so we need to wait, we need to run. So here, so it is automatically functioning. So 1 check, then 0 0, then 1 1, then 0 0, then 0 1, then 1, then 1 1 1. I don't know what's wrong with here. But yeah, for overall, it's the result. Thank you.